In this video, we'll look at doing operations with radicals. So there are two questions. Let's start with the one on the left. Question A says the square root of 12 plus the square root of 18 minus the square root of 27 plus the square root of 50. So the first thing is you can't add or subtract roots when they're like this. This is a different root. Each one is different. The only way we could add or subtract them is if there were the same root. If we had like root 12 plus root 12 or root 27 minus root, but we don't. However, we can change all these roots, and let's see how to do that. I want to make these roots into something times something where one of those numbers is a perfect square. As in, what times what makes 12? You could do 1 times 12, but that doesn't change anything. You could even do 2 times 6. But neither 2 nor 6 is a perfect square. However, 3 times 4 is a perfect square. And that's good because we'll see in the next line, we're going to make this root 3 times 4 the same as root 3 times root 4. Look at that. We've broken down root 12 into root of 3 times 4, which is the same as root 3 times root 4. And that's cool because root 3 times root 4 is the same as root 4 is just 2. So 2 root 3. I just made this root 4 into a 2 and put it out front. That's how I'm going to work all these pieces. I did the first part of each line to show you it's going to become that. Let's look at root 18. Root 18, what times what makes 18? Where one of those numbers is a perfect square? 2 times 9. 2 times 9 becomes root 2 times root 9. And what's root 9? Just 3. So we get 3 times root 2, or 3 root 2. If it's bothering you that I'm doing root 3 and then moving it out front, sorry, root 9 is 3 and moving out front, you could write that step, or you could make sure to put the perfect square first. Let's do that with 27. What times what makes 27? Just two numbers, where one of them is a perfect square. 9 times 3. 9 times 3 is 27. Now I've got this perfect square in front that's minus root 9 times root 3. And what's root 9? 3. This is a perfect square that gives you 3 root 3, the minus in front here. And now just the plus 50. Do you have to do each piece like this? No, you could do a whole line of just break down the factors. What's the root of 50? I have to make it into something times something where 1's a perfect square, like 25 times 2. This 25 is a perfect square. This becomes root 25 times root 2. And the square root of 25 is just 5. So you get plus 5 root 2. Now that we've broken it down into these perfect squares that left just a root here, notice we have, they're not technically like terms, they're technically more like roots, but you can think of it like terms. We've got this and this, which are both root 3's. Those can be added or subtracted. In this case, 2 root 3 minus 3 root 3 gives negative root 3, or negative 1 root 3, but we don't write the 1. I've got negative root 3, and plus we have these same radicals, 3 root 2 and 5 root 2. Think of it like terms. If you had 3x plus 5x, you just have 8x. So what's 3 root 2 plus 5 root 2? 8 root 2. And we're done. Can you add a root 3 to a root 2? Nope. This is as simplified as possible. And more importantly, it's an exact answer. There was no rounding. That's operations with radicals. There's another type of operation we can do, and that's when you're given two sets of brackets here. We want to expand this or FOIL this. I recommend you watch the video on expanding with FOIL 2 ways. I'm going to use that FOIL technique to multiply this first thing times the first thing, and this outside thing times the outside thing, or this number times both of these. So what happens when you do 3 root 3 times root 3? You get 3 root 3 times root 3. It's just this times this times this. Now I'm going to do 3 root 3 times negative 2 root 2. So I get plus 3 times root 3 times negative 2 times root 2. That's from this times this. Don't worry, it looks big. It's going to get simple. Now I'm going to do the inside times inside and last times last, or this times root 3 and this times negative 2 root 2. What do I get? I get plus 4 root 2. Better make sure that root covers the whole way if I want good communication marks. So I got 4 root 2 root 3. And now I've got 4 plus 4 times root 2 times negative 2 times root 2. Do you need all these brackets? Some of them you don't need. I just like writing them because lots of students forget to put brackets around this negative 2. You definitely need it around that. Otherwise it would be takeaway 2. It's supposed to be times negative 2. Okay, let's watch it simplify very nicely. Here I have 3 and then times root 3 root 3 times root 3. That's easy. Root 3 times root 3 is just 3. When you multiply a root times a root, they cancel out and you just get what's inside. Over here, I've got 3 times negative 2. I'm going to multiply the numbers first. 3 times negative 2, that's negative 6. And now multiply the roots. Root 3 times root 2, that's just root 6. Okay, over here, 4 times, well, I can't do much with that 4, but I can again do root 2 times root 3, just multiply the numbers inside. You get root 6. And then at the end there, I get 4 times negative 2. 4 times negative 2 is negative 8. And then root 2 times root 2. Here's another way to think of it. What's root 2 times root 2? That's just root 4. What's the square root of 4? 2. Root 2 times root 2 is just 2. So I get 3 times 3 is 9. And now like terms here and here. I get not really like terms. They're like roots. Minus 6 root 6s plus 4 root 6s is plus 2 root 6s. And then minus 8 times 2 is minus 16. And so the like terms are just the numbers here. What's 9? Take away 16. You get negative 7. And then, whoa, this isn't plus 2. It's a negative 2. Look, I made a mistake here. Minus 6 plus 4 root 6, that shouldn't be positive 2. Minus 6, then go up 4. You're at negative 2 root 6. Good thing I caught that. So I added, let me just check again. I added these like roots, yeah, negative 2 root 6, and then 9 take away 16 is negative 7. So my final answer is negative 7 minus 2 root 6. And that's operations with radicals.